next concept that we are going to start with is geometric progression. Geometric progression. So what's a geometric progression? Again, as I told you, it's a sequence where the subsequent term is obtained by multiplying the preceding with a common ratio, right? So as you can see, R here is the common ratio, which is nothing but it's the ratio of the subsequent term to the preceding. That means your n plus 1th term is obtained by multiplying R to the preceding term. Okay. Just like in case of an AP, the difference between the two terms wherein the difference between two terms was fixed, that was called the common difference. Here the ratio of the succeeding to the preceding, again note the word here, ratio of the succeeding to the preceding. Don't do it the other way around. That is not the common ratio. Common ratio is always the succeeding divided by the preceding. Okay, so here please note that R cannot be 0. Because if R is 0, that means you're trying to say your n plus 1th term, if R is becoming 0, what will happen? Your n plus 1th term will become a 0. And if that happens, then you are trying to say that Tn plus 2 by 0 is equal to 0 or equal to R. This is not possible. You cannot divide by a 0. Okay. So very important information that I would like to give you here. Please note, no term in a GP can be 0. Okay. So there cannot exist any term which is 0 in a geometric progression. Please make a note of this. Arithmetic progression can have a term as 0 in it. That is not a problem. But geometric progression cannot have a term which is 0. Right? Now, how would I find out the expression for the nth term over here? If you see the pattern, from the pattern also you can answer this. So the first term contains AR to the power 0, second term contains AR to the power 1, third term contains AR to the power 2, etc. So your nth term would contain AR to the power n minus 1. Okay, so this is your nth term. Another way to look at it is, if you use this particular nature of a geometric progression or this pattern, in this pattern you can start putting your n as, let's say, 1. Okay, so if you put n as 1, you get T2 by T1. Okay, that is equal to R. N as 2, T3 by T2, that is also equal to R. And so on till n minus 1, you will get Tn by Tn minus 1 is also equal to R. Let's multiply all of them. Let's multiply all of them. Dot, 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 dot. Oh, sorry. Okay, so when you multiply, you will realize that these terms will start cancelling off. Okay, so this term will get cancelled off with this will get cancelled off with this will get cancelled off with this. Eventually, what will happen is that on the right side, you will have R to the power n minus 1 because there are n minus 1 R's. And on the left hand side, you'll get Tn by T1, which is nothing but this. So your Tn is T1 into R to the power n minus 1. So if you're calling T1 as A, then this will become your nth term of a geometric progression. Okay. So again, I would like to reiterate this. In a geometric progression, R cannot be 0. It can be positive, it can be negative, it can be a fraction, it can be an imaginary number also, but it cannot be 0. It cannot be 0. Okay. All right. So without much ado, we can move on for a question on this, if at all we have any. Or we can take up sum of n terms, then we can start doing questions. Sum of n terms of a geometric progression. So let's say if you have been given a geometric series, something like this, how will I find the sum till n terms of this geometric series? Okay. Now, unlike the method that we had used in our AP, if you try to reverse this and add it, we all know that it's not going to give you, the sum is not going to give you a fixed term added n number of times. So what is the approach that we are going to use over here? The approach that we are going to use over here is we are going to multiply this entire series with the common ratio r. Okay. So if you multiply a with r, you'll get ar. Let us write it one shifted to the right. If you multiply ar with r, you get ar square. Again, let's write one shifted to the right. This will be ar cube, and so on till we get something like this. Okay, so what I did, again, I would like to repeat. The entire series, I started multiplying with r. R is the common ratio. Okay, and the terms that I obtained after multiplication with r, I wrote it one shifted to the right. Now what I'm going to do is I'm going to subtract both of them. Okay, so if you subtract s minus rs is like s times 1 minus r. A, let's say I have 0 over here if nothing is there, and let's say I take 0 here. So a minus 0 will be a. Okay, this will be cancelling off. In fact, I'm subtracting it. So this will be cancelling off, cancelling off, cancelling off, cancelling off, and I will have minus a r to the power n over here. Okay. In other words, S1 minus R is A times 1 minus R to the power n. Okay. So S could be written as A times 1 minus R to the power n by 1 minus R. You can also write it as A R to the power n minus 1 by R minus 1. Okay. You can also write it as L into R minus A by R minus 1. What is L? L is the last term. Okay, so last term into the common ratio. So if you know your last term, first term, you know your common ratio, then you can also find the, basically you don't need the number of terms there. So you can also find out the sum by the use of this formula. Now there is some misconception in the schools or with the children that this formula is to be used when mod r is less than 1. This formula is to be used when mod r is greater than 1. There's nothing like that. Okay. See, both are same formula. It's just that you are taking a minus common from the numerator and denominator and cancelling it off. Okay. So it's a wrong notion to say that this is used when mod r is less than 1 and this is used when mod r is greater than 1. No. Please do not fall for those myths and misconceptions. Okay. Both the formulas are same exactly. Now the problem here occurs when you are dealing with r equal to 1. Okay. What will happen to this formula if r is equal to 1? Won't it become 0 by 0? So this formula fails when our common ratio is 1. Does it fail, by the way, or is it a way to work around that? Absolutely, guys and girls. Very good. When r becomes 1, this formula doesn't fail actually. This formula, we have to take the limiting case as r tends to 1. So if r tends to 1, take a limiting case of this. Okay. So we all know that this term is very much like, try to recall, you have done this in your limits chapter. Try to recall limit x tending to a, x to the power n minus a to the power n by x minus a. What is it? N a to the power n minus 1. So think as if your r is x, your a is 1, right? So this will become a times, this guy will give n a to the power n minus 1. That actually gives you a n, which is correct also, because if you have a common ratio of 1, you know that all these terms will be a n number of times. So that will end up giving you an only. Okay. So this formula doesn't fail actually, but you have to take the limiting case of this formula when r tends to 1. Okay. Any questions with respect to this? Please note down, because I'm going to change the slide and I'm going to go to the next page. Done? See Aditya, when you put your r as 1, it actually becomes an indeterminate case. When it becomes an indeterminate case, we have to involve a limit, else we'll not be able to find the answer. Because for r equal to 1, both numerator and denominator starts becoming 0. So tending to 1 will give you the answer, exactly 1 will not give you the answer. Is it clear, Aditya? But by simple add, we can see r can be 1, right? Yeah, see, r can be 1, but how does math justify those cases? If you get a formula, how does math justify those cases? It says that in case where r becomes 1, the formula can be made valid by using a limiting case. Okay, I understand your concern where you are trying to say that r can be equal to 1, but when you take a limit, r can never achieve 1, right? So when you try to match the two results, we do it by taking the limiting case. That's all we can say here. Yeah. Okay. All right. So we'll now move on to the next page. Now there are certain geometric progressions, or there are certain geometric series, I should say, which are convergent in nature. So if your modulus of r is less than 1, your series actually can be found out. That is, the sum of n terms can be found out where n tends to infinity. Okay. In a geometric progression, if modulus of r is less than 1, then even S infinity can be found out. I'm not saying S infinity will only exist. You can find out till n terms also, but your n can exist to or n can extend to infinity as well. Okay. So in such cases, your series becomes convergent in nature. Okay. By the way, those who are preparing for APs, those who want to go abroad, AP Calculus BC will consist of the last chapter as series where you have to study about convergence. So there are a lot of tests for convergence, ratios test, comparison test, Rabi's test, etc. Integral test. So those who are interested in studying more about the series or the convergence, you can always Google it out, or you can always find a lot of videos on YouTube talking about convergence. Now, many people are still confused about what do you mean by convergent series. Convergent series is basically that series where even if you are summing up till infinitely many terms, your answer is finite. Many people have this wrong conception that a convergent series is a series where the subsequent terms starts diminishing. That is a necessary condition, but that is not an essential condition for you. That is a necessary condition, but that is not a sufficient condition for you to have a convergent series. Even if the terms are decreasing, the sum of infinite terms may not be finite. It may become very large. Okay. A typical example is a harmonic progression which goes like this: 1, 1 by 2, 1 by 3, and so on till 1 by n. If n becomes very, very large, this sum is still infinity. Okay, getting the point? So even if the terms are diminishing, it is not a convergent series. So please do not have this wrong impression in your mind that convergent series is a series where the subsequent term is lesser than the preceding. No. Even if it is, it need not be convergent. Convergent definition, if you want to know the core definition of a convergent series, it is where your sum of infinite terms is still a finite number. So this is not a convergent series. Okay. Anyways, we'll not spend a lot of time talking about it. Yes. The sum can become a zero. Absolutely, why not? Sum can become a zero. Okay. Yeah. So for a convergent series, only for a convergent series, we can find out the sum till infinity. So how we can find out? Let's take the limiting case of n tending to infinity on this particular expression. Okay. Now I would like you to recall what we did in our limits chapter. When modulus of r is less than 1 and you raise it to a very, very large power, then this term will start vanishing. This term will start going to 0. So as a result, this guy will start vanishing. As a result, your answer will be something like this, which is nothing but a by 1 minus r. So please remember, if a geometric progression satisfies this condition on the common ratio, then the sum till infinity can be found out, and that answer would be this. Okay, please make a note of this. Now we can take up few problems on this concept. Can I go to the next page? Have you all copied it out? Okay. A very simple question we'll start with. If sine theta root 2 sine theta plus 1 and 6 sine theta plus 6 are in GP, then find the fifth term. The poll is on. Let's have around 1.5 minutes, not more than that. One and a half minutes gone. I've got only 2 responses. Guys and girls, please buck up. Okay, at the count of 5, we'll stop. 5, 4, 3, 2, 1, go. Okay, maximum of you have voted for B. Okay, let's check whether B is correct or not. See, let's say I call this term as A, I call this term as B, and I call this term as C. Okay, so if they are in GP, B by A should be equal to C by B. That means B square should be equal to AC, isn't it? That means square of the middle term, square of this term should be equal to sine theta into 6 sine theta plus 1. Okay, so what I'm going to do here is I'm just going to write it as 2 sine theta plus 1 the whole square. This is 6 times sine theta sine theta plus 1. So now sine theta plus 1 we can easily cancel out from both the sides. Why we can cancel it out? Can somebody tell me that? Can't sine theta be minus 1? Yes, Aditya, absolutely correct. If you keep sine theta as minus 1, your terms here and here will become a 0. What did I say? No term in a GP can be 0. Okay. If they are in GP, you cannot afford to have sine theta as minus 1. Because if it is, your second term and third term will become 0, which is not allowed. Okay. That means 2 is equal to 4 sine theta. That means sine theta is equal to half. Okay. If you put it over here, your terms will be like half. Okay. Next term will be 3 by 2 root 2. Okay. And the next term will be, I think, 9, isn't it? So what is the common ratio here? The common ratio is 3 root 2. Common ratio is 3 root 2. First term is half. So they're asking us the fifth term. So fifth term is this 3 root 2 to the power of 4. That will be your answer. And I think this is going to give you 3 to the power 4, which is going to be 81. And this is going to be 2 into 2 divided by 2. Answer is 162, option number C. Janta, C got second, I mean, highest went for B. It is actually C. Is this fine? Any questions? Any questions? Any concerns? Silly mistake? Okay. Let's move on to the next one. If A, B, C are real numbers such that, as you can see the big expression on your screen, then A, B, C are in which of the following? Let's have around 2.5 minutes for this as well. Time starts now. Very good. Last 1 minute. Okay, 5, 4, 3, 2, 1. Please vote, please vote. Okay, only 11 of you, 12 of you were active, 13 of you were active, and you have given a distress call to C. Sorry, distress call to B. B is the most chosen option when people don't know the answer. Okay, anyways. So let's check whether B was correct or it was just out of distress that you could not solve it. See, look at this term very carefully. See, I'm going to write this down in a very special way. 3a square, 3b square, 3c square plus 3 minus 2ab minus 2bc minus 2ca minus 2a minus 2b minus 2c equal to 0. Okay, so what I did was I brought everything to the left side. Okay, now let me make up some groupings. A square plus b square minus 2ab one group, a square plus c square minus 2ac or 2ca one group, a square, sorry, b square plus c square minus 2bc one group, then a square minus 2a plus 1 one group, b square minus 2b plus 1 another group, and c square minus 2c plus 1 another group. As you can see here, what I did was this 3a square, I split it up like this: a square here, a square here, a square here. This b square also similarly I split it up in these positions. C square also I split it up here, here, here. Minus 2ab is here, minus 2bc is here, minus 2ca is here, minus 2a is here, minus 2b is here, minus 2c is here, and this 3 I split it up as 1, 1, 1. Okay. Now, why at all I did that is because, as you can see here, they are all perfect squares. Okay. And if they are real numbers, note that they have categorically mentioned that they are real numbers. Real number squares can never be negative. So if they're adding up to give you a 0, and these are all supposed to be greater than equal to quantities, then it can only happen when these are individually 0, 0, 0, 0, 0. Correct? If they're individually 0 means A is equal to B, A is also equal to C, B is also equal to C, so B is equal to C, and A is also equal to 1, B is also equal to 1, C is also equal to 1. So it can happen only under the condition where A, B, C are all equal to each other and they are 1 each. And hence it could be both in GP and AP. So those who marked B thought that, oh, sir is doing GP. So he must have given a GP question. So let's mark B. B was unfortunately wrong. Option C is correct. Yeah, the common difference can be 0. Another common ratio cannot be 0. Common difference can be, if at all they are in AP. Okay. All right. All right. So let's take this question. Very similar to what we did for AP. There's a set of natural numbers which are partitioned like this. Find the sum of the numbers in S50. Please give me your response on the chat box in whatever convenient notation you can use. Find the sum of the numbers in S50, 50th set. Observe the pattern and then act. Very good, Aditya. Nice. Anybody else? Okay, okay. I think 1 minute is good enough. Anurag? All right, let's discuss it, boys and girls, ladies and gentlemen. See here, if you see, focus on the first term. This is 1. This is actually 2. 2 is nothing but, you can say, okay, let me write it like this. 1. This term is like 2 to the power 0. S2 was having 2 and 3. I'm focusing on the first term. First term is 2 to the power 1. S3 has 4, 5, 6, 7. So this first term here is nothing but 2 to the power 2. As you can see, whatever is the set number, 1 less than that is raised to the power of 2. So if this is 3, 1 less than that is this. Correct? Yes or no? So if I go till S50, S50 will have the first term as 2 to the power 49. Next term will have 2 to the power 49 plus 1, then 2 to the power 49 plus 2. Da 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 da. How many terms would be there? Now that is also very important. See here, first term has 1 term, second term has 2 to the power 1 term, third term has 2 to the power 2 term. So I can say there will be 2 to the power 49 terms over here. Okay. So this is an arithmetic progression, so as to say, which has got first term as 2 to the power 49, common difference is 1, and the number of terms are also 2 to the power 49. So the sum will be 2 to the power 49 by 2 into twice of the first term plus total number of terms minus 1 into common difference, which is 1 here. On simplification, this will give you 2 to the power 48. This is 2 to the power 50. This is 2 to the power 49 minus 1. And if you want, you can club these two terms by taking 2 to the power 49 common. So it'll give you 2 plus 1 minus 1. So this is nothing but 2 to the power 48 times 3 times 2 to the power 49 minus 1, which gives you 3 into 2 to the power 97 minus 2 to the power 48. Absolutely correct. Very, very correct. Aditya, I think you was the only person to get this right. Okay. Any questions here? Do let me know. Any questions? Any concerns? Do let me know. Okay. 2 to the power 50. Ayyo Rama, it is a big number. Why would you like to calculate it? Okay. Good, sir. Let us move on to the next question. Okay, let's do this question. If x is 1 plus a square a cube up till infinity, and y is 1 plus b square b cube up till infinity, and it's known that a and b are basically numbers between 0 to 1, show that. It's a show that question. So you just have to do it and let me know it is done. So we have to prove 1 plus ab a square b cube etc. till infinity is given by xy by x plus y minus 1. Let's do this. It's a very simple question. I don't think so more than 2 minutes is required for this. Just reply with done on the chat box. Done? Anybody? Okay. Now from this particular series, it is very evident that this guy is your infinite geometric progression whose first term is 1, common ratio is a. Correct? Yes or no? So x is 1 by 1 minus a. Similarly, y is 1 by 1 minus b. Correct? And this term, whatever it is, let's write it as the same series dot 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 till infinity. This term is what? This term is 1 by 1 minus ab. Isn't it? Now, from this expression, can I say 1 minus a is 1 by x? So a is equal to 1 minus 1 by x, that is nothing but x minus 1 by x. Similarly, b would be y minus 1 by y. So this expression I can write it as 1 minus ab. ab is nothing but x minus 1 by x into y minus 1 by y. Any questions, any concerns? Okay. Now, if you take the LCM over here, it will become xy minus x minus 1, y minus 1, and xy will also go on the top. If you expand it, it will give you xy minus x minus y plus 1, which on opening the bracket will conveniently result into the desired expression, x plus y minus 1. Okay, hence proved. Hence shown, in fact, not proved, hence shown. Any questions here? Please do ask. So after having got A and B values, I substituted it over here. Okay. Yeah, that's fine. That's fine, Anurag. Not an issue. Okay, any questions here? Anybody? Okay. Next question. We'll come to this question a little later on. All right. A1, A2, A3, etc. are in GP, where AI belongs to C. C being complex numbers, set of complex numbers. Having R as the common ratio such that sum of A2k minus 1, A with a subscript as 2k minus 1, is same as sum of A2k plus 3, which is not equal to 0 each, then the number of possible values of R is. Very easy question. Don't get carried away with the complexity of the expressions given to you. It can be solved within 30 seconds. It is such an easy question. Meanwhile, I'll give you 1.5 minutes for it. Time starts. Only 2 response. 1.5 minutes already gone. I thought this was a super easy question. Okay, at the count of 5, we'll stop. 5, 4, 3, 2, 1, go. Okay. Maximum number of people have voted for C. C for Chennai. Let's check. See what is given to us. If you put K as 1, you get A1, then A3, then A5, then A7, till A2n minus 1. And here if you put 1, you get A5, A7, A9, A11, till A2n plus 3. Am I right? Now, we know that these terms are themselves in GP. Right? See here, they're in GP. So can I write A5 as A1 r to the power 4? Can I write A7 as A3 r to the power 4? Can I write AN as A5 r to the power 4 and so on? That means if I take r to the power 4, common from this, it will be A1, A3, A7, till A2n minus 1. And on this side also we have A1, A3, A5 till A2n minus 1. And we know they are not 0 because they have categorically mentioned that none of these are 0, so they can be cancelled off. That means 1 is equal to r to the power 4, which gives you 4 values of r, which is plus minus 1 and plus minus I. Option C is correct. As I already told you when I was introducing geometric progressions to you, that common ratio can also be imaginary numbers. Okay. So this question was actually not worth more than 30 seconds. All right, let's take this question. This is a passage-based question which has got three subparts into it. Read the question first of all of you carefully. The question is talking about a unit square. Unit square means a square with side unity, whose sides have been divided into a certain ratio. Alpha is to 1 minus alpha, as you can see on the diagram. And when you connect these points, which are basically dividing the outer square, you get another square. And you keep maintaining the same ratio and keep doing it for infinitely many times. So the question is, if alpha is 1, find the least value of n for which the area is less than 1 by 10. An is the area of the nth square. So read the question properly and then attempt it. Let's have around 3 minutes for the first part. Your time starts now. This is just the answer for 12th. Please do not solve any other question. Only for 12th I am doing right now. So this poll is just for the question number 12. All right, last 30 seconds. Only 2 people have voted. Okay, 5, 4, 3, 2, 1, go. All right, most people have voted for option number B. Let's check. So guys, first of all, let's take any nth square. So in this diagram, I'll make up any nth square. Okay, so this is your nth square. Okay. So now what I'll do, I'll start, making these points. Let's say I take it. Yeah. So these are the points which divide. Oh, sorry. I have to choose lines from here. Yeah. Yeah. So what I'm going to do is I'm going to make up n plus 1th square within it. Okay. Yeah. So this white one is your n plus 1th square. Okay. Now let us say this whole length was an. This whole length was small an. And this length was an plus 1. Okay. And let's say the area of this square is capital An, and the area of this square is capital An plus 1. Okay. Now, first of all, we all know that this ratio is 1 minus alpha is to alpha. So I can safely assume that this length from here to here, let me name it A, B, C. This length is 1 minus alpha An, and this is alpha An. And here I'm going to use a Pythagoras theorem. Okay. So if I use Pythagoras theorem, An plus 1 square is 1 minus alpha An square, alpha An square. That means An square is nothing but 1 minus alpha square plus alpha square. So this is An plus 1 square. Any doubt till this extent? Anyone has doubt to this extent, please do let me know immediately. Okay. Now, this is nothing but capital An plus 1, and this is nothing but capital An. Okay. And here you can simplify it to 2 alpha square minus 2 alpha plus 1. So I can say An plus 1 by An is 2 alpha square minus 2 alpha plus 1. Please make a note of this. Now, let us address the question. The question is saying alpha is 1/3. If alpha is 1/3, can I say An plus 1 by An will be nothing but 2 by 9 minus 2 by 3 plus 1. Let's simplify this. This is going to be 2 by 9 minus 6 by 9 plus 1. Oh, sorry, 6 by 9 plus 1. This is nothing but 5 by 9. Yeah. So what you learn from here is that the area of these triangles would be in geometric progression, isn't it? So if the ratio of this term becomes a constant quantity, what does it mean? What does it mean? It means A1, A2, A3, till whatever term are in geometric progression with common ratio as 5 by 9. So if you want to find your An will simply become A1 into 5 by 9 to the power n minus 1. And this is something which is less than 1 by 10 as per the question. Now remember, A1 is 1 because you are starting with the outermost square. Outermost square is a unit square. So basically you're trying to solve this question. Now, whenever you're trying to solve these kind of questions, you have to take help from the options. Let's start with the minimum or the value 4. Does 4 satisfy it? If 4 would satisfy it, then n by 9 by 5 to the power 3 will be less than 0.1, which is like saying 625 is less than 72.9, which is not correct. So 4 is gone. So 4 cannot be my answer. Does 5 satisfy it? Let's check. So 5 by 9 to the power 4 is less than 0.1. So that means 6. Oh, my bad. Sorry, it's not 125. 125, not 625. Okay. Now this is 625 and this is less than 9 to the power 4. 9 to the power 4 will be how much? 81 into 81. 81 into 81 will be 16, 1, 16, 1, 6, 1, 7, 6, 1, right? Am I right? Oh, sorry. I'm very sorry. 64. This is 6561. Yeah, 6561. So 656.1. Yes, this is correct. So the least of the value that I see is 5. Option number B is correct. So C and D cannot be the answer. Option number B, B for Bengaluru, is what you also have said. Very well done. Now I would like you to attempt question number 13. 13 will become simple because I have already done half the work for you. So I'll just give you 1 minute for 13, not more than that. Your time starts now. Find the value of alpha for which summation an from 1 to infinity is 8 by 3. All right, 5, 4, 3, 2, 1, go. Go. Take a call. B. Okay, anyways, only 6 of you have voted. Never mind. Out of 6, 4 of you have said B. B for Bengaluru. Now see, what is sum till in terms? Sum till infinite terms. Sum till infinite terms for an would be nothing but a1 by 1 minus the common ratio. A1 is 1. Remember, common ratio was this guy. 2 alpha square minus 2 alpha plus 1. I hope you can see it over here. This is your common ratio. This is given to you as 8 by 3. Correct? So let's cross multiply. So 8 times 2 alpha minus 2 alpha square is equal to 3. Correct me if I'm wrong. So 16 alpha square minus 16 alpha plus 3 is equal to 0. I think this is factorizable. Yeah, 16 alpha square minus 12 alpha minus 4 alpha plus 3 equal to 0. Take 4 alpha common, 4 alpha minus 3, take minus 1 common, 4 alpha minus 3 equal to 0. So this gives you 4 alpha minus 1, 4 alpha minus 1 and 4 alpha minus 3 equal to 0. So alpha is 1/4 or 3/4. Vanta is absolutely correct. Option number B is the right option, even though you had taken a guesswork. B is correct. Now, let's have question number 14 quickly also. Again, 1 minute for this. And I'll put the poll. Okay, Pranav. Good. Pranav has given his response. Find alpha if the side of the n plus 1 square equals to the diagonal of the n plus 1 square. Fifteen seconds more. 15 seconds. Okay, 5, 4, 3, 2, 1, go. Okay, C is the most chosen option. C is the most chosen option. Let's discuss. See, what is given to us, I'll do it over here. What is given to us is that the side length of the nth square is the diagonal of the n plus 1th square, right? So this is given to us. That means an plus 1 by an is 1 by root 2. So let's square it. If I square it, can I say an plus 1 by an is given to us as 1 by 2, which is actually the common ratio, which happens to be 2 alpha square minus 2 alpha plus 1. So that means 1 is equal to 4 alpha square minus 4 alpha plus 2. That means 4 alpha square minus 4 alpha plus 1 is equal to 0. This is a perfect square, which clearly means alpha is half. So 1 by 2 is absolutely correct. Option C, Janta was absolutely correct. Option C is the right option. Any questions? Okay, guys. So I'll do one more thing. I'll just quickly wrap up. Sir, it's the diagonal of the n plus 1th square. Huh? What is wrong in that? Diagonal of the n plus 1th square will be root 2a n plus 1, no? Yeah, Aditya. So what is the problem in that? An is diagonal equal to the diagonal of the n plus 1th square. So an is root 2a n plus 1, no? Ah, okay. Okay. So guys, with this we'll conclude the geometric progression part.